Okay, so let's start Engineering Mechanics 201, Engineering Mechanics 1, Engineering 201, Lecture 16. Okay, today is going to be the review for the final exam. In the name of the Father, Son, Holy Spirit, Amen. Direct, the Lord, beseech you, our actions by holy inspirations and carried on by grace assistance, that every preparing work of ours may begin always from you, and through come to completion, through Christ our Lord. Amen. Father, Son, Holy Spirit. Amen. All right, guys. So let me open here the review problems that I prepared for today. I believe I have, where's it? 1, 2, 3, 4, 5 problems here. Okay. We're going to review those topics that are going to be at the final exam. Okay. There's going to be 4 topics in the final exams. In the final exam, the shear moment diagram, the truss, the centroids, and also the 2D equilibrium of a body, okay, which is pretty much the equilibrium equations as we're going to do as well for the shear moment diagram. Okay, so just one more for you to do. Okay, so I'll start with the shear moment diagrams. Okay, and after these 5 problems, if we have time, I'm going to go over and highlight a few things from the homework that was due last night. Okay, if you have any other questions, please let me know. Okay, I can meet you anytime that works for me, for you as well. We can chat, we can exchange emails. Okay, tomorrow, Wednesday, this Wednesday is going to be a study day, so if you have any questions, please let me know. Watch the videos, watch the review. Okay, go over the notes, go over the homework solutions that is already posted. And Thursday, same thing that we did for the midterm. Take the exam anytime that you'd like to take during the day. Okay, and then once you finish, I'll grade it as soon as possible. Friday, Saturday, Sunday, I have to report the grade to the university, if I'm not wrong, by Monday afternoon. So if you have any questions regarding your grade, please let me know during the weekend. Sounds good? All right, so let's start. Starting by drawing the shear moment diagram for this beam. All right, so we have it simply support beam A and B here. We have this distributed force and a concentrate force. Okay, although we have this point C right there, okay, we're not going to use this exactly. Ordinate is going to be the location for the equivalent load. Okay, and we have point D here for this concentrate force. Okay, but before that, what we have to do is how we start any problem. Okay, is the reactions. Okay, reactions AY, AX, in this case BY. Okay, so we are done with this class. So I want you to leave this class, Engineering 201, knowing, okay, how to find the reactions. Okay, what kind of support or what kind of reactions a support is bringing to the problem. Okay, on the left we have this pin support. On the right we have this roller support. Okay, so what kind of reactions? BY, AXAY. Okay, another thing that I wanted to leave this class is, this is simply just uniform distributed load. So how can I find the equivalent force for this in order for me to calculate reactions? Well, what I'm going to do is it's going to be right here in the middle of this uniform distributed load. If this is 6, if one side is 6, one side is 6, another side is 6, this is 12. So right here I have 0.5 times 12, which is going to be 6 kips. Okay, with that I can then do this equations of equilibrium equations, and I will have AX equal to 0 because I don't have x, another x in x force. Sum the force in y equal to 0. I will have a y positive, -6, -5, positive by. Okay, so I know ay plus by should be 11. And they have some of the moment, about a. Okay, and what I have is going to be 6 times 6. Okay, I'm talking about this 6 here, times 6. However, this is a clockwise. Clockwise for the equilibrium equations is going to be negative. And then I have -5 times 18. Okay, -5 again is not because it's going down. This -5 is because the rotation here is going to be clockwise. 6, 6, 6, 3 times 6, 18, 5 times 18. And then by times 18 plus 6 is going to be 24. So I have plus by 24 to 0. By my calculation here, please make sure, okay, double check. 5.25 is by, keeps. Ay is 575 keeps. Okay? Now, I'll solve the problem. What the problem is asking me to draw the shear moment diagram. Okay? So please, show me your steps. Okay, show me everything. Okay, show me every detail that you are doing and solving, so I understand what you're doing. Please do not throw numbers in your test. Okay, I had a few of you doing that, or it was the other class I'm teaching. I don't remember, but please make sure you have a good flow of your calculation. All right, especially for this shear moment diagram. Please show me your calculation for the shear. Okay, we're gonna get there for the area of the shear. Show me the area of the shear diagram. Okay, do not throw numbers. All right, do it in a clean way, clear way that I can understand your graph. If it's possible, try to do what I'm doing here. Okay, right below my drawing, I'm gonna leave space if you wanted to print it out and solve it at your home, or at least try to draw kind of in the same orientation. Okay, so right here, for example, right here I'm going to draw the shear diagram. So the shear diagram from here to here, A to B. Okay, so let me get today you can see my rulers, see what I'm doing here. Okay, so getting my important points. Okay, important points or discontinuity points is where I have a discontinuity on the loads. Okay, so A is where I start the beam. So it's an important point. C, right there, is not, right now, is not an important point anymore because the load is uniform. I not change the load at point C. The load is still the same. Okay, I still have the uniform load. But the end of my uniform loading is an important point because the load stopped. Then D is another important point. And B, of course, another one. Okay, so this is it's going to be for my shear. So later on, I can draw the moment diagram. Shear diagram is going to be in keeps. Okay, starting from the left to the right, we can follow that rule, up and down. AY 575. So I can go here all the way there, say that this is going to be 575. Okay, now I have distributed force. If I have distributed force, I'll not go straight because this force is already acting down. Okay, it's already pushing me down. But it's a uniform force where I'm gonna have to, at the end, go down 6. So if I'm at 575, go down 6, I'll stop at the end right here, 0.25. Okay, and because this is no slope, okay, constant slope, here, zero, okay, zero slope, okay, that's a load, 0.5 kips per foot, the uniform, okay, order of lines, think about this, just a straight line, no slope. This one here, we're gonna have some slope, constant slope. This one is constant slope. And the slope of this line, okay, how much I'm decreasing in this line here is 0.5. Okay, so each foot I decrease, okay, 0.5. So run 1, decrease 0.5. Okay, or rise negative 0.5. Okay, run and rise. I will continue this one here. This part here, I don't have any uniform distributed load. I don't have any load. So if I don't have any load, so I keep straight, okay, up to this point. And that point, I do have a load being introduced to the problem, which is 5 kips down. So 5 kips, I'll go all the way to 525. And then I'll finish here straight, and by is going to push me back to 0. All right. And I forgot this is negative, of course. This is negative, of course. Okay. For my area, it's important for me to keep the negatives. All right. So now what I need to do, okay? You made a clean shear diagram, which is great. Now you need to calculate the areas, okay? Show me the label, what is area 1, area 2, area 3, area 4? Okay, show me that one so I can see what you're calculating. A1, this is going to be A2, it's going to be A3, it's going to be A4, okay? If it's possible. Now you start the problem. Let me calculate A1. And then what you see? You see that, oh, I have a triangle. But in that triangle, I have 575, but I don't know what is the x, the base of this triangle. So let's find, okay? What is this x here? Okay, how can I find this x? It's just 575, your peak, okay? Divided by your slope. What is the slope? Oh, why am I taking this one? What is the slope? 0.5. 0.5 is the slope. So 0.75 divided by 0.5 is going to be 11.5 feet. If this is 11.5 feet and my total one is 12, okay? Well, in other words, this is 0.5. 0.5. Okay, so now I can calculate area 1. Area 1 is going to be 575 times 11.5 divided by 2. Area 2, let me put, negative 0.25 times half divided by 2. Area 3, negative 0.25 times 6. That's it, times 6. Area 4, negative 525 times 6. Okay? Then you calculate the areas. Here I have my calculation, so let me get it here in my notes. 33. Here I left all the decimals, which is okay. So let me leave all the decimals here for the calculation. And again, I believe you guys saw the solution for the midterm and compare your answers. Okay, if not, go and do that. And you saw that even though I solved by using another decimal place, decimal numbers, okay, if your answer was close enough because you showed me your steps, so I knew what you were doing. I knew that you consider the cosine as, I don't know, 32.5 the angle as 32.67 instead of 32.665. Okay, so I follow your logic, calculate. If your calculation was correct, it's correct. Okay, doesn't need to be exact as mine. Each one of you probably is going to use different decimal numbers, but try to keep at least like two decimal numbers. Okay, as much as possible. Then I have here negative 1.5 and negative 31.5. Okay, that said, I'll do the moment diagram. But if right here is enough, this is the moment diagram. Keeps foot. Okay, I will start. So before I start the moment diagram, let me take a look here and see if I have any concentrate moment, because I have to pay attention to those details. Right here, I don't have any concentrate moment. Okay, so I can just follow, I will follow only the shear diagram. Okay, so area 1 is going to be the change from moment at the point A to the end, or to that specific point of area 1, the end of area 1. Okay, so pretty much I have now another, okay, if I can say like that, I have another important point here. Okay, because is when my moments will change. Okay, so this area is going to be 5 sine 5 times this 11.5 divided by 2, 33. So I'll go to, I can go up to here. It's going to be, so this one is 3306.25. And then that plus this difference, okay, will push me to 33. Plus this difference, okay, I have to decrease that much, 1.5. I'll go to 31.5. And then 31.5, I'll go back to 0. Now I just need to pay attention how to link those lines, okay? For example, A3, A4 is straightforward because I have just no slope in A3 and A4. Here I'll have this inclined line, okay? Now, many of you have questions how I link, how is going to be the curve of those triangles. We have these triangles, okay, incline. So how is going to be the curve right here? It'll be like this or like that, okay? For those, take a look where we have shear 0. Shear 0 is right here. If the shear 0 means the slope at this point should be 0. What is the slope 0? It's kind of a straight line here, okay? So what is the curve that goes like that? This curve or that curve? The second one. Okay, so this is how it's going to be. Okay, so this is my moment diagram for this. Can I? No. Let me paint. All right, so this is my moment diagram. That one is my shear diagram. All right, any questions? Those who are here, any questions? All good? All right, so let's do one more, okay? One more, because I want to review this one here. When we have this moment concentrate moment or this couple moment, okay? How we deal with it. Once again, reactions, AY, BY, BX. Sum of the force in X equals 0, BX, 0. Sum of the force in Y equal to 0, AY plus BY equal to 10. Sum of the moments about A. Okay, so far so good. Sum of the moments about A equal to 0. Let's start from the right. Okay, let's start from the right. So this is going to be negative 10 times 4.5 positive by times 3 ay no moment. And what about 30? 30 is already counterclockwise, so it's going to be positive 30, and no distance, okay? No distance because this is already a moment, okay? At the end, I'll find by 5 kilonewtons, ay 5 kilonewtons as well, okay? Take a look, see if you agree with that. All right. Shear diagram. What is 30 kilonewtons per meter, 30 kilonewtons meter is doing in the shear diagram? What this 30 kilonewton meters is introducing to this shear diagram? What is introducing? Nothing, okay? This 30 kilonewton meters, this moment, this couple moment, doesn't do anything for the shear diagram. It's not doing any shear, it's doing moment, okay? So let's forget about him. So we start at 0. We don't have any shear. We don't have any shear up to AY. AY, we do have shear. Then 5. And then we keep going. No shear, up to this point. BY, we're going to introduce 5 more. This is going to be 10. No shear, up to this point, going back to 0. Okay? Well, area 1, area 2, area 3, A1, 0. No area. A2, 5 times 3, 15. A3, 10 times 1.5, 15. All of them positive. And then we'll go to the moment. Okay. Then my question is, what is this 30 kilonewton meters introducing to the moment? Is doing anything for the moment diagram? Yes, because the moment. And here comes my saying again, okay? Please do not confuse yourself. This is equilibrium equations. For the equilibrium equations, what happened? Moment is positive counterclockwise. Equilibrium equations. However, here we are talking about moment diagram. Moment diagram is respect to the behavior of the being with the moment. positive moment, negative moment, okay? Meaning the shape that this will become, okay? This will become, all right? This one here, what's this gonna be introduced? How is gonna be that? Okay, if you don't know, you're gonna get your paper, okay? Your test. You're gonna hold a little bit after 30 is introduced. So right here, after 30 is introduced, and you're gonna apply this 30, that's gonna pushing down, sad face, negative. So this 30 is a negative moment, okay? It's a negative moment, all right? So this should be going down. Negative 30, okay? Bruno, if I don't know, if I'm confused, well, check your areas. Once you sum the areas, should go back to zero. The summation of areas should be zero. Here we have 0, 15, 15, and both of them positive. So we have positive 30. We are missing negative 30. Where is this negative 30? Right there. Okay? So negative 30. Then from this point, oh, I'm getting confused with this ruler every single time because something changed here in this app. Now the ruler is the last one that I can click. Used to be my pointer. So from this point to that point, area is 0. So I don't have any change. Constant moment. Okay, take a look. Constant moment. No change at all. Okay. Now from this point, negative 30. What a horrible point was that. Okay. Negative 30. From that point to the other point is 15. Okay, plus 15. So I'll go to negative 15, then back to 0. And there's going to be straight line, straight line. All right? So this is my moment. Okay, very straightforward problem just for you to review and keep in mind about concentrate moments. Okay, those are my questions for shear moment diagram. Any questions for those who are here? Type in the chat. Any questions or open your mic.
No questions.
Sounds good. So let's go for next problem, which is, okay, the trust problem. Okay, so let me tell you a few things about the trust problem. Okay, in the class we learned two methods: method of joints, method of sections. In the test, in the final exam, I'm going to allow you to use any method. So if you want to solve by using method of joint, please do so. If you want to solve use the method of sections, please do so. Okay? Bruno, does that mean that I can just save my energy and study one of those methods? Yes. Okay, please. You don't need to study both of the methods. Okay, choose the one that you like the most, you feel more comfortable, you understand the most, and get good on it. Okay, get good on it, get better on it these next 2 days. All right. For this one here, I'm going to solve by using methods of sections. Okay, sections. I think a little bit more confusing. The sections. I will try to be straightforward as possible for this problem. Okay, and then another thing that I would like to tell you is the following. I understand that the homework problems were a little bit more challenge than this one I'm gonna solve. Okay, but just to bring some peace to you, okay, the final exam is going to be a little bit more this style question number 3 that you see right now than those different trust shapes that I have in the homework. Okay, the homework is good for you to make a case, failure, understand, go again. Okay, that's why the homework is a little bit more difficult, just for you to failure, learn from failure, get back and try to solve it, okay? Because maximize your learning curve, okay? But keep calm, okay? The midterm question is not going to be a very complex shape. It's going to be kind of a normal truss for you to solve, okay? With that said, being said, so let's start this problem. I want to find city, CG, and HG. Okay, those three members. So as I said, you can use joints, you can use sections. This one here, I will use sections. And let me tell you one thing again. To make the cut in section, we need to start outside the truss. 1, 2, 3, and go out the other side, okay? Up to 3 members, and you need to start outside, go to outside, okay? We need to split it in be able kind of to split it, separate them, okay? I cannot come just here and make a cut only in this member, okay? It's not gonna work. It's not gonna work, all right? So we need to do these 3 cuts. All right, with that said, so let me calculate the reactions, okay, because I'm gonna use the reactions here. A Y, A X, F, Y, okay? Before I solve, let me just mention that this is very symmetric truss, okay? 80, 80, the distance are the same, so 3 meters, 3 meters, 3 meters. Without doing any calculation, okay, without doing any calculation, I know AY is gonna be 80 and FY is gonna be 80, okay? Because it's symmetric, okay? But I will do the calculation here, so I just want to mention to you. Sum of the force in X should be 0, AX, 0. Force at Y, AY plus FY, 160. Moment at A, negative 80, 3, negative 80 times 6, positive Fy times 9, equal to 0. Fy, 80 kilonewtons, Ay, 80 kilonewtons. All right. Sections, what I do, make the cut, select one of the side. This one, let me select the left-hand side. So for the left-hand side, I will have the following. Okay, let me draw the free body diagram here so we can visualize. So this is B, this is C, this is A, this is H, okay? Now, let's draw the external force. What external force I have? External force, 80 kilonewtons. And AY here, 80 kilonewtons. Okay? AX is 0, so not bringing AX here. Now let's draw the internal force. Internal force, I do have FCD. This one here, FCG. And this one, FHG. Okay, let me just complete here so I have some distance, maybe some other points that I can use. Okay, but this completion, okay, this drawing here is not part of my section, so that's why I'm just drawing the distance. I'm not bringing the 80 kilonewtons at point D because this was thrown off. Okay, I'm not using this, just the distance here. Maybe I can use it to calculate any of the moments, okay? And then I can start the problem. All right? Remember, sections, you have three equations. Sum of the force in x, sum of the force in y, and sum of the moments at any point. A, B, C, D, H, G. Okay? Any of those points you can use the sum of the moments. All right? I see FCG is inclined, so let's just discuss quickly about the angle, but I believe everybody got it. Okay, angle theta, this is what? 3, 3, okay, 3, 3, 45, 45. Okay, those angles here, 45 degrees. Okay, but please, in the final exam, find your angle, make sure what is sine, what is cosine, okay, all of that. With that in mind, guys, quickly, sum of the force in x is going to work here for me. I have FCD, FHG, and also FCG x component. So I have three unknowns for sum of the force in x. Three unknowns. Okay, so not going to work right now. Sum of the force in y. Sum of the force in y, well, sum of the force y is going to work. I have just FCG y component. I know, and those are just x. So sum of the force in y is going to work. And moments. In some moments I can find as well. For example, I can do the moment about C. Moment about C, I can find FHG. Okay? So let's do that. Let's start with the sum of the force in y. Okay? You could start sum of the force in C. You could start with sum of the force in y. Another one, you could start sum of the force in some of the moments about G. Okay? So those two are canceled. And you find FCD, another option. Okay? So depending on what you want to do. In this case here, okay, take a look what's going to happen. I have negative 80. Sorry, start from the left. Positive 80. Negative 80. And this component here, which is going to be negative FCG cosine of theta. Take a look what's going to happen. FCG cosine theta equal to 0. Those two cancel. FCG 0. 0. Bruno, can it happen? Yes. Sometimes a member is there just for being there. Of course, not just for being there, to bring stability to the truss, of course, but it's not doing anything, any internal force. There is no internal force. So even though I have those forces here, that member is not in tension, is not in compression. Okay? That's 0. Is not happen anything on it. Okay? All right, so this is 0. I found 1. Okay? Now let's do the others. What I said the moment about C. Moment about C. So we can find FHG. So moment about C, take a look. Let's analyze together. 80, not doing any moment. FCG, FCB, no moment. FCG, no moment, but anyway, it's 0, so doesn't matter. Okay. 80, yes, moment, times 3, negative. Okay. FHG, yes, times 3, positive. Okay. So I have negative 80 times 3 positive FHG times 3 equal to 0. FHG equal to 80 kilonewtons. It's positive, it's going to be in tension. Okay? Now with that, I can do the sum of the force in X. Okay? Because I have FCD. FCG is 0, so no. Plus FHG. FCD is what I'm trying to find. This is positive 80 to 0. FCD is negative 80 kilonewtons in compression. Okay? So it was a very straightforward problem. Okay? Just to review a few things. All right? Remember, and I can show it in the homework as well at the end of this lecture. Remember the following. Try to follow your free body diagram. So this is important, okay? Try to follow it every single time. Even though, for example, I got a negative here, okay? Do not go there and change, get confused. Just work with the negative, okay? Consider the force being that way for other case. And the hour that you're gonna substitute by negative 80. Okay, bring the negative 80 to the calculations. Okay. But please do the free body diagram so you understand the force. You keep it referring your calculation to that free body diagram. Okay. Sounds good? Sounds good. This is different, for example. If AX was negative or AY was negative, I would come here and change this already to create a new free body diagram for my other problem. So this would be negative 80 already. Okay. So for this case, I like to bring the negative here to the free body diagram already. But once I create this free body diagram for my section, I'm going to just refer to it every single time. Okay? At least I think it's easier. Okay. Just a tip for you. Any questions? Okay. Next problem, centroid problem. Oh, I forgot to put here the table for the centroid, but I have the equations here. I solve it. Please, if I forgot, if you cannot see the table for centroids during the test, feel free to open it and check it out. Okay, but I'll make a note for me to post it together with the question. All right, so centroid. So centroid, I need to find the centroid of this shape. Okay, so what I need to split this shape in small parts. Okay, I need to find the centroids for the small parts. Okay, and I will do the equation. Okay, centroid of a small part x times area, x times area divided by the sum of the areas. And for y, same thing, y times area divided by the sum of areas. Okay, so which shapes I'm gonna use here? Okay, this problem, other problems, the final exam problem, you have some options. So please show me your steps. It's important. Once again, show me your steps. Show me the shapes you're selecting. Show me what is the shape number 1, what is shape number 2, what is shape number 3, 4, 5, 6, 7. Okay? This case, my solution here, because I don't have the table, so I'm going to copy my solution. I use 3 shapes. This triangle here, okay? This full rectangle, which I will call shape number 1, shape number 2, and this is going to be my shape number 3, this quarter circle here. Okay? What you could use? You could use shape number 1 like this big rectangle, and remove this triangle and remove this quarter circle. It's going to work. It's going to work. All right? So it's up to you. With that, I need to find the centroid of each one of those my shapes. Okay, for this rectangle, I know it's right in the middle. For the triangle, it's close to the peak of this triangle, so it's going to be right here. Okay. For the quarter circle, you can check it out the table later, but I'll let you know that's right here. Okay, it's from this corner where I have the right angle, 9-degree angles here. Okay, it's going to be from this corner a little bit there. Okay, and how much is going to be this one? This one here is going to be, if you go to the table, 4r 3 pi, and right here as well, 4r 3 pi. I don't know if you remember, for the triangle from this corner is going to be h over 3, and this is going to be base over 3. All right, me get nice here. With that, let's make the table. Shape number 1, this triangle. Then I will have x bar in its, y bar in its, and area in this square. Okay, shape number 2. Shape number 3. Right? Let's start. X bar for shape number 1. Remember, it's not going to be b over 3. It's from the y, from the axis, how much you're going to run or you're going to walk from this y-axis in x. Okay, so I'm going to walk all the way to here. So it's going to be this much here. Okay, this much. And what is this much? Okay, that much is going to be 2b over 3. Or you can think the total base minus b over 3. The way that you like to think about. Okay? If this is 4, all the way there, just to let you know, is 8 inches. Okay? 4 plus the radius here is 4. So 4, and right here is 4. All right? So this would be 2 times 8 divided by 3. This is 5.33. Or 8 minus b over 3. Okay? Y. Same thing, should be here to there, to the axis. The total here is 9 up to here, plus h over 3. So this is 9 plus h over 3. This case is going to be 10. Sounds good? Area. Now area, pay attention. Area is this base times the height. Okay, it's not this base times, for example, 10 that you just calculate. So keep in mind. Do not look here. Go here, what's the area of this triangle? 8 times 3. 8 times 3. Divide by 2, of course. It's going to be 12. Rectangle. Right in the middle. In x, 4. In y, Half of 9.5. Oh, it's half of 9, 4.5. So this is 8 divided by 2, 4. This is 9 divided by 2, 4.5. Now this triangle, yes, is 8 times 9, okay, 72. All right. Quarter circle, the same thing here. Okay. The distance here is 4r 3 pi. However, I need the distance from here to there. So I can write 8 minus 4r 3 pi. Okay. Meaning 8 minus 4 times 4 divided by 3 pi. By my calculation, this is 6.3. Okay. Y is different. Okay. It's just 4r 3 pi. 4r 3 pi. In my calculation, I have 1.698. Okay. 698. Now the area of a quarter circle, if you go to the table, is pi r squared divided by 4. However, what we are doing with this area? We are removing this area. So this should be negative area. Okay. So this should be like this. Negative 1257. Once you calculate. Okay. 1257. X bar. Let me put it here. Like this. X bar 5.33 times 12 plus 72. Sorry. 4 times 72 plus 6.3 times negative 1257 divided by 1272 negative 1257. By my calculation, this is 382 inches. And y bar is going to be 10 times 12. 4.5 times 72. 1698 negative 1257 divided by 1272 1257. By my calculation, 492 inches. Okay. If you don't need to show me the final exam, but if you want to show x382 around here, and then 592 around to 4.5 right here, 4 and then 2 maybe here, maybe somewhere here. This is x bar. That one is the centroid of that shape. Okay, so things for you to remember. Those exactly the same thing that I did here, okay? That distance from here to there, okay, is not only what is in the table. Please pay attention on that, okay? Summing, for example, this is h over 3, but should be all the way down. So summing this distance. What else? When you have to remove area, negative area, okay? And I think that's it, okay? I think that's pretty much it for this intro. Any questions? Okay. So let me go to the last question that I have prepared here. Member ABC is 6 meters long, with point B being at its midpoint. Determine all force acting on member ABC. Okay, meaning reactions, excuse me, these and B, we have like a cable. So the reaction that cable, the tension that cable as well. So that's what we want to find. So first thing, reactions. What reaction does we have here? Pin support. AY, AX. Okay. Even though it was not specified that it was a pin, we understand this is pin support. Okay. B is a cable. Okay. What do we have in a cable? Tension. Okay. Trying to hold this structure ABC. Okay. So tension B. Okay. And what about C? C, we have this 300 kilograms. So in that cable is going to be this weight here. Okay. And pay attention, guys. I had a few of you still using the kilograms in your calculation. Okay. You need to change it to newtons. I have been using 9.81. Okay. Some of you use 9.8, which was fine. But if you can, for the final exam, please use 9.81. Okay. So it's going to be a little bit easier to check the answers. So 300 times 9.81 is going to be 9,943 newtons. Okay. But Bruno, I used kilograms and I got everything right, but it wasn't kilograms. Yeah, I understand, but it should be newtons. Okay. I discount a few points or 1 point, 2 points, I don't know. Okay. But it should be newtons. Okay. Tension in newtons. Okay. For the midterm. For this one, if you got something in kilograms, please change in newtons. All right. So this is what we have. Okay. By doing that, I have a good picture now, and I can do the sum of the force in x, sum of the force in y at the moment. Okay? But analyzing here, this is inclined. So when I do the sum of the force in x, y in the moment, I need to find its component. So let me find already the component. Okay? This is TB, something, the angle. Which angle, Bruno? Well, let's talk about this angle here. The angle here. What is this angle? Okay. This one is easy, right? Put like this. Look what we have here. This beautiful triangle, right? 45, 45. 45 degrees. Bruno, I don't have, I don't know how to find that angle. Okay, this one was straightforward. How I do that? I believe I show you. Yeah, I show you for the truss. Did I show you guys here? Let me think about it. I believe so. Okay, I believe so. So this was, for example, right here. Okay. Let's say we have this right here, and these are my axes, and those are the incline in incline, meaning that this angle 45, okay, 45 degrees, right there, okay, it's gonna be right here, 45, right there, 45, right there, 45. Actually, let me change this. So this is the angle green. This is the angle green 45. And this is the pink 45. Okay. So I'm talking about this pink here. This pink. So if I have to do this one here, is going to be this 45 here that you can see. This 45 is this one here. See? And then this one would be another thing, which is going to be, in this case, all 45. So it's confusing, but this is the green one. Okay. Then the 45 would be right there again. Okay, for when we have a shape like this. And then we have the green one. And as you can see here, we have the green one right here. Like this. That's what we have here. So that's why this is the green or this is the pink. Okay. You can create visual like that. Okay. Create visual like this with the angles. Those are 45, so is straightforward. However, I'll try to, for those problems, if we have something inclined, I'll try to be specific on the angles, okay, for you. But this is going to be the sine of the angle theta, cosine of that angle as well. So what we have for this problem is sum of the force in x equal to 0. What do we have in x? Ax positive, tb cosine, the angle 0. Ax, tb cosine. Sum of the force in y should be 0. Ay plus tb sine negative 2943. Okay. Now ay plus tb sine should be 2943. Zero. Now for the moment, actually, I don't have any other distance than this 6 meter long ABC and B is the midpoint. So this is 3 meters. This is 3 meters. Okay. I don't know this full, for example, this full distance here. Okay. And that distance there. I don't know, but I know the angle, I know the diagonal. Sine of angle, sine of 45, y over 6. Y is 6 sine of 45. Cosine of 45, x over 6. X is going to be 6 cosine 45. So now I know x and y. So y is important because for the moment, some of the moments at A should be 0. I do have started from the right. W negative 2943 times the distance x, 6 cosine 45, plus TB sine. TB sine is half distance of x. Okay, similar triangles. So this is going to be TB sine of 45 times, I put 6 cosine 45 divided by 2 plus TB cosine and half distance of y. So this is going to be TB cosine 6 sine 45 divided by 2. And all of these should be equal to 0. Okay? With that, can we do something here? Yes. Just calculate it. Okay, we have TB is the only unknown. We're going to find TB. Once you do this calculation, TB is going to be, if not wrong, is twice this one here. No, not twice. Missing something. No, so this is 2943. Let me calculate this one. 2943 times sine 6 cosine 45, 12,000. This is going to be sine and cosine of 45 are the same. Sine, cosine, 45 is the same. So this is going to be the same. Divide by 2, so just 1. And then I'm going to divide by that. Divide by sine 45 times 6 times sine 45. All right. So TB, that's the number I was looking for. 4162. Close to that. 4162 newtons. Okay, once you do this calculation, please do so. And then I will go back there, find, and I go back there here. Later I'll go back here. I'll find AX equal to 4162 cosine 45. Actually, yes, 2943 newtons. And I will go back there as well. I will find this one here is going to be AY 0. Okay? Because this is going to be 243. 243 go the other side, 0. AY is 0. All right, that's it. That's why I remember I didn't have this one solved all the way to the end. But I remember those numbers that was half and 0. Or the double and 0. Not the double, but the divided by cosine. All right, so that's how we solve these different problems, okay? Inclines or different bodies, but pretty much doing the equilibrium equations. That's what you can expect to find on the midterm, on the final exam, sorry. Okay, even though we are doing pretty much the same thing every single time here, okay, for those and also for the shear moment diagram, they're just okay, they're sometimes complex case, okay, but I want to bring maybe a twist, maybe something is not only a beam, maybe a bar, maybe another application. I would decide it, but something different from what we have been doing of the shear moment diagram, the truss, okay, something a little bit different so you can work in the equilibrium equations, okay? Um, so that's it. That's it for the review, okay? Um, again, before I go to the homework, okay? Shear moment diagram, okay? Don't forget. Truss. Okay. Select joint or sections. Okay. And then centroid. Okay. Use the table. You can use the table. Table is fine. Just pay attention what you're doing. And then 2D rigid body. Okay. If you are comfortable doing the equilibrium equations for the beams or the truss, you should be able to do the last problem to do to the rigid body. Okay? Should be able. With that said, let me jump now. I'll do just show a few highlights from the homework. Okay? Because some of you asked me. And then I'll finish. If you have any questions, please let me know. Okay, take a look here. The homework number 1, question number 1. And make sure you find the reactions correct. It's right here. I already posted the solution, so please make sure. Okay. For this one, I didn't give you y. Okay, in order to calculate this angle. Okay, you're gonna need later on. Okay, to calculate this angle here, so you can find this angle later on by using this 30 degrees, of course, 30 degrees and this 6. Okay, you find this y, so you can find this angle right here. Okay, if you use the method of joints, which I believe everybody use because I ask for every single member in each member of the truss, which, by the way, I'm not gonna ask every single member in the final exam. I'm gonna ask for a few of them. Okay, so that's why you can use the section, you can use the joints. What else? What I can say about this? I started at A. Take a look here. I started at A, very simple. Okay, A, E, A, B. Okay. I got it positive, got it negative. What I like to do when I'm using the metal joint, I like to come here and tell what is tension, what is compression. So I can come to joint, okay, I'll come to it later. But then I went to joint C because I had 2 unknowns. So in joints, 2 unknowns is my most, okay, up to 2 unknowns. So I did some of the force in Y, some of the force in X. I flipped it here just because if I did the X before, I couldn't find. So I already flipped my solution, got a negative, got a positive, come here, write down. Okay, so I can come here, for example, joint B. Where's joint B? Right here. I know this one, I know this one, I don't know, I don't know. 2 unknowns now, so I can solve B. But then that's why I need this angle. So at the end, okay, what I did, this is tension, this is tension. So those orientations, they are already good. 450. Those I don't know, I assume tension. I gotta be 0, BD 0. Take a look, 2 zeros here. Okay, 2 zeros. So those members, no force on those members. Okay, and join D, that's what I use to finalize. I just want to bring your attention to the following. DE, I don't know. Okay, DE, I don't know. So I assume tension. DC, I know this is already compression. So what I'm gonna do, I'm gonna come here and put the compression. Okay, this is how I solve this problem. Bruno, can I assume tension and come here? What is CD? Right here, and I see negative 520. Yes, then your solution is gonna be a little bit different. You're gonna be DE, okay, and then if you do the sum of the force in X and Y, depending how you're doing that, okay, you're gonna get the same, DE negative. However, just the free body diagram is gonna be different, okay? But what I like to do is, for the joints, only for the joints, I like to create the free body diagram following what I already know. I know this is a compression, so that's why this 520 is in compression, okay? So that's a little bit different from what I told you for this section. For this section, I'm not changing the free body diagram. I'm taking the same section, the same free body diagram, and just using it again and again. For the joint, each joint is a new free body diagram. So that's why I like to change. It's going to be up to you. But please pay attention to those signs, okay? If it's compression or tension. Question number 2, same. So the reactions here, we're going to get a HY negative. I make the cut, and here I select the bottom, okay? The bottom. You could select the top and do not use the reactions, okay? So you could skip all of these and use the top, all right? But please pay attention here. Once I select the bottom, this 15 should be there, okay? Those other 3, throw away. If you select the top, 1, 2, 3 external force, okay? Then you cut. Then do it in your moments and keep going, okay? Sounds good? There's this section that I did it in the review. In the shear diagram here, moment diagram, again, shear, no force, down, down, go here, then all the way down, up, okay? Area, 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 this is straightforward, okay? No problem for this one here. For this one, what do we have? Distribute, and then we have a force here, I have a force there, okay? When at any time that we have a force or a reaction and a distributed force, please split it. So that's what I did in my solution. I split it, calculate this one here, 0.8, calculate this one here, 1.6, solve this one, then I have the CY, then I have the distributed force again, okay? Here, parabolic like this, and then parabolic like this. This one is easier because this one goes to 0. So this should be coming this way here, 0 slope. For those two, you can think about these numbers. 11.2 like negative 11.2, and this is going to be negative 12. So you're going to decrease more here. So you're not going back to 0 like this. Okay, you should go all the way like this, because it's just decreasing more and more, okay? This one is one of the problems that I solved in the review today. 36 kilonewtons is the moment, concentrate moment. So just pay attention here. This is a negative moment, negative 36. And then area number 1, exactly the same thing. You need to find X. How I find X? For 49.2, which is this peak divided by the slope, 15. Okay, I have how much this is X. I have this A2, the rest of it. Calculate the areas, okay? Once you sum this area, you're going to see that it's missing negative 36. Another way for you to know that this is negative 36. And my last problem, yes, my last problem here, okay? My concentrate moment is in the middle, just for you to visualize what's going to happen. In the shear diagram, nothing's going to happen in the middle, just going to keep straight. And then right here, we have that. And once again, this is for the equilibrium equation is a negative moment because it's clockwise. However, for the moment diagram, this is going to be a positive moment. Why? Let me get my... Think about holding a little bit after D. Okay, after D, you hold and you apply this 3600. Okay, this rotation like this. Okay, as you can see, say D is pushing up my structure. This structure here that I'm moving is the ACD. A is on this top, CD, let's think about like this ACD. So this is pushing up. Okay, up, smile face, positive, goes up that much, and then go down. All right? So quickly review here of the homework. If you have any questions, please let me know. Review it, study my notes from the lectures, watch the lectures again, okay, watch the review again, and let me know if you have any other questions, okay? Be ready for the exam, okay? If you're not ready, study again, email me, ask me questions, okay? Tell me your situation, okay? So this is the last sprint for you to get it done. Sounds good, guys. I will stop here. I will see you next time. Okay, I will take the moment now just to thank you guys for watching the lectures, for being good students. Most of you are delivering homeworks, doing a good job. So I hope you guys enjoy this summer. Please let me know if you have any other questions regarding your future classes, okay? In Engineering 201, you took Engineering 201 now. So if you are civil engineering, you can take Engineering 301 or CE 312. If you're mechanical engineering, you can take Engineering 301. If you're biomed engineer, I think you can take biodynamics, something like that. Okay, check with your chair, with your advisor. All right. One last thing, I send you a feedback form, so if you can fill it out, feedback form, I would appreciate it as well. Okay? Any questions before I finish here? All good? Okay. Okay, so I will stay here a little bit more if you guys have any questions, but for those watching it, take care. Thank you so much. See you next time.